bad. Well, it's not really my bad. You are probably ill. Okay. We need a formula that would transform a z-score into an x value. So we need it to equal x. We need it to look like this. X equals. And this is what we know. We know that x minus mu over sigma equals z. So I need somebody who's willing to transform this into this. And to be brave enough to possibly get it wrong in front of other people. Emma's willing. Anybody else? Sierra, good. Anybody else? Caleb's willing to? Come on, who cares? What if you get it wrong? Thomas is willing to? Nobody else? All right, Emma, you're 1. Thomas is 2. Sierra, you're 3, and Caleb is 4. 2. Proof. Yep. All right, I'm gonna write right here, x minus mu over sigma equals z. Take me through it. How do I transform it into x equals?
Multiplied by the mu.
By the mu?
Or by
Are you talking about this thing on top or the thing on the bottom?
on the bottom.
That's sigma, yep. So it'd be x minus mu equals z times sigma now, right? Because if I multiply by sigma here and sigma there, those cancel out. Add mu. So it's mu plus z times sigma. That's correct. And that's actually in your book. Mu plus z times sigma. You don't even have to really know this formula, frankly. You could just start plugging things into other places and then solve for x every time if you wanted to, but this formula does make it a little easier. So what this is going to do for us, is this is going to make it so we can look at story problems where we have a percentage that we want, and then we find the data point that matches that. Buy some more pens. Okay, so a veterinarian records the weights of cats treated at a clinic. The weights are normally distributed. That means a bell curve has a mean of 9, a standard deviation of 2 pounds. Find the weight x corresponding to the z-scores of 1.96, negative 0.44, and 0. Okay, I'm sorry that that negative is over there instead of over there. Just how it worked in the word program I was using. So I'm going to write down that our mean is 9, our standard deviation is 2, and we need to find x that corresponds to 1.96. Okay, so normally cats are 9 pounds. If a cat is 1.96, does that mean that they are a super skinny cat or a super fat cat? Fat compared to the average, right? Okay, so to figure this out, we're going to do x equals mu, which is 9, plus a z-score, which is 1.96, times sigma 2. Just filling stuff into the formula. That cat is 12.92 pounds. I once had a cat that was over 20 pounds. His name was Checkers. He was a lot. He was also very friendly, absolutely loved me, loved everybody else. Have I told you this story, how I got destroyed by Checkers once in a hammock? All right, well, once I'm done with this video, I'll do it. I don't think Mason needs to hear that story again. All right, so that is our first one, 12.92 pounds. To find the second one, you would use the exact same formula. The only thing you're changing is what? The 1.96. So it changes to negative 0.44. which should be 8.12 pounds. You do not have to put the last one in your calculator. If something's z-score is 0, what is their weight? What? The mu, yeah, the average. So the third one is just 9 pounds. Because if you are exactly a z-score of 0, that means you're exactly average. So the cat's 9 pounds. All right, really quick, do number 3B with your partner. I'm going to do them up here so you can compare your answers. If you're done, lean over, take a look at your partner, make sure they're doing it right. Remember, this is a story problem, and story problems have story answers, which means you have to have a label on these. If you don't have a label on the free response section of the stats exam, they will not give you points for that problem. Is this that hard? No. The challenging part about this chapter is throwing it all together at once. Where it's like, okay, right now they've given me a percentile, so I need to find a z-score and work backwards. Or right now I have this stuff, ooh, I need to use the chart this way and go this way. So the hard part is when it's all together and they are not doing all of the same problem over and over again. Are we all okay on this one? 17.05 and 98.5 pounds? Beautiful. All right, let's get a little bit more complicated now. Scores for the California Peace Officer Standards and Training Test are normally distributed with a mean of 50 and a standard deviation of 10. An agency will only hire applicants with scores in the top 10%. What is the lowest score an applicant can earn and still be eligible to be hired by the agency? Okay, so what's the lowest score an applicant can earn and still be eligible to be hired by the agency? All right, let's draw a picture. When in doubt, draw a picture. It's a bell curve, right? Because it's normal. We know that the mean is 50, average score is 50 with a standard deviation of 10. An agency will only hire applicants with scores in the top 10%. By the way, some companies actually do this. Like, if you're thinking, yeah, but what if everybody scores really high? Well, then the 10% moves. And they only take the applicants in the top 10%. I had a course at UW-Madison, the psychology department.